I'm only graphing -1 here to just sort of like frame where we're going.
Mm-hmm.
But you can see here, it approaches some value. It looks like it approaches 7. Now see how it's undefined? Can't quite get on it, but it's undefined
Mm-hmm.
there.
Yeah.
There's a reason for that, but you only care about what it approaches.
Mm-hmm.
And it approaches the y value of 7.
Okay.
And so part B, and I'm going to snip that into the other space for that. So the truth is that a lot of calculus can be done with just a graphing tool like that.
Okay.
Okay, so we'll go back to the other screen. And you can see here that, if you graph them, you just look at the output basically.
Oh, okay.
All right. Now, yeah, I mean, I'm hesitant. I mean, I don't want to lead you in the wrong direction, but yeah, let's do this. So, next question here, it says to evaluate graphically, round your answer to the nearest 2 decimal places. So everything to the right of the limit is what would go into your graphing tool or your calculator that you're using. So let me go back to where we were. We'll graph it again, and we'll see if we can make any sense of this. Actually, 1 plus 3x. Now in Desmos, if you have a fractional exponent, you'd have to put it in parentheses.
Mm-hmm.
Now this time we want the value as x approaches 0. Ooh, okay. So this one's pretty tough because you can see at 0.001, it's 19.996.
Mm-hmm.
But at going the other way, at minus 0.001, it's 20.176. So to me, it's 20.
Okay.
Roughly. Now there's a better way to do this also. And let me go to the Desmos scientific. Have you ever used this before?
No, I haven't.
Okay, so it's somewhat useful. Let's say x is 0, and you write x equals 0, and then you type in 1 plus 3x to the power of 1 over x. It's going to tell you it's undefined, okay?
Mm-hmm.
But let's make x something really, really, really small. Okay, now we've got a number. So if we make it smaller, we actually get a better answer. And this is the better way to answer this problem, is using this calculator.
Okay.
Because the limit just means like what is the output really, really close to that. And it doesn't matter whether you're positive or negative, you're gonna get the same value there. So it looks like it's really 20.09. And these are shortcuts that I'm showing you. These are not I don't know, they're not tricks or anything. They're just shortcuts. I will do the problems that you're going to need later in this course. We'll learn how to do those, but these you will not be doing limits ever again in this course.
Okay, perfect.
So the graph really kind of worked against us, but the calculator, really is pretty helpful for these. Any questions on that?
No, that makes sense.
Okay, now 3A. All right, so this is one of those problems where the only way to do it is by hand. It says use the limit definition of the derivative to find f prime of x for each of the following. Now, depending on where you are in the course, you may already know how to take the derivative of this without the definition of the derivative. But the definition of the derivative, this is like one of those common test questions that they ask. It's the limit as h goes to 0, f of x plus h minus f of x over h. Have you seen that before?
Yeah, I think I have.
Okay, that is the definition of the derivative. It looks really formal, but you already have an f of x. So now you just need f of x plus h, which means wherever you see an x, you're going to put in x plus h.
Okay.
So that's minus 17x minus 17h minus 15. And you do want to simplify or expand, I guess, in this case. So this definition of the derivative, the f of x plus h is all this stuff that we just wrote down. So you're just going to substitute in replacing f of x plus h with minus 17x minus 17h minus 15 minus, in parentheses, f of x. And that's where you go grab the original function, minus 17x minus 15 all over h. You
Okay.
probably see why you can't use a calculator or something for this.
Yeah.
It doesn't help. Now there are online calculators for finding this, but that's a different story. Limit as h goes to 0. So we have minus 17x minus 17h minus 15 plus 17x plus 15. You should see some cancellations in the numerator. You should see that anything with an x cancels like that.
Mhm.
So you're left with limit as h goes to 0 minus 17h over h. You can simplify. So that becomes the limit as h goes to 0 of minus 17. There's no 0 to put in for h anymore. Like it's been canceled out. So this is your final answer. This is the derivative.
Okay.
So whenever you see a problem like the one we just did where it says use the definition of the derivative, you're going to use that horrible f of x plus h minus f of x over h.
Mhm.
You're gonna do it, one more time. Limit as h goes to 0, f of x plus h minus f of x over h. So they have to give you an f of x. That's for sure. They have to give you an f of x, and they
Mhm.
have. You have to calculate f of x plus h, which is 2 times x plus h squared minus 6 times x plus h minus 3. So the faster you can expand binomials, and as a reminder that this is really x plus h times x plus h,
Mhm.
the faster you can do this manipulation, which is your previous courses, the faster it's going to be for you. Okay, so if there's any questions on this, like, please, ask me. I'll show some of the steps here,
Okay.
but this is there, like, you're supposed to know this, like, and they might even say that in the classroom, hey.
Mhm.
So all of this that I just wrote, which looks like a lot, it's the f of x plus h. So it's the limit
Yeah.
as h goes to 0. And because I got a little digital format here, I can just copy and paste. But, there's a lot of writing. Like there's truly a lot of writing. Minus f of x, 2x squared minus 6x minus 3. Make sure you put it in parentheses, all over h. Now it does get better, but you got some work to do. You got to
Yeah.
distribute that negative, and then you get to see all these cancellations. Minus 2x squared plus 6x plus 3 all over h. So your check that you've done it right is that everything in the numerator that's left over has to have an h in it. It just has to. And the reason is because you're dividing by h.
Okay.
So if you still see something with an h without an h, like an x, you've done something wrong, and you want to look for that. Okay, so this time you divide each of these by h, all three. It's not a choice. You got to divide them all.
Mhm.
Limit as h goes to 0. Get rid of that. So you got 4x plus 2h minus 6.
Mhm.
Now this time you still have an h. Remember in the previous one, all the h's were gone. So
Yeah.
you do substitute in for h. So it's 4x plus 2 times 0 minus 6. So that's 4x minus 6. 2 times 0 is 0. So if you have an h remaining, as long as it's not in the bottom, which is the whole point of this, you you will sometimes put that value in.
Mhm.
Okay. Now, are you taking like a calculus class that's like for pharmacy students, or is it like you're not in there with like the engineers and the
I think it's just like a regular calculus class for everyone. But for pharmacy, I am required to take calculus. But I think it's just like everyone who is taking calculus. I don't think it's just limited to pharmacy students.
okay. Fantastic. Now it looks like there's a C. Oh no, there it is. Okay, there is a 3C. Yeah, okay. Is this okay?
Yeah, that's fine.
All right. So like at the University of Arizona, they have a calculus class for business students.
Oh, interesting.
It's very different. And that's because there's actually a bunch of limit definition questions that are kind of standard on tests. But
Mhm.
I don't want to give them to you if you don't need them.
Oh,
Okay, so they have to give you an f of x, and then immediately you find f of x plus h. So that's 2 over 3 times x plus h. We're not going to simplify that yet. So the limit as h goes to 0, f of x plus h. So it's 2 over 3x plus h minus 2 over 3x all over h. And that's the definition of the derivative.
okay.
And now this is where, like, if you haven't done this problem before, you have no idea what to do next.
Mhm.
So when you get fractions in numerator like this, you make a common denominator. So the common denominator is 3x x plus h. And so that means this one's missing an x and an x, and this one's missing an x plus h and an x plus h. So we'll show that in the next line here. Limit h goes to 0, 2x over 3x x plus h minus 2x plus h 3x x plus h all over h. So now that they have the same bottom, you can combine the tops. So the top is 2x. This minus 2 gets distributed in minus 2x minus 2h all over 3x times x plus h. Limit as h goes to 0. All over h. There it is. Sorry.
Mhm.
Okay. Now, kind of again that check, that built-in check, like did your x terms cancel, or you just left with something in h, and you are, so that's good.
Mhm.
You're like, all right, I think I'm doing this right. I'm on the right track. So it's minus 2h over 3x times x plus h. Now, kind of off to the side here, if I said 1 over 2 over 3, you may not remember this, but this 3 actually just comes up here. So this becomes 1 over 2 times 3, or 1/6. The reason is you have 1/2 divided by 3. That's the same as 1/2 times the reciprocal, which is obviously 1/6. So if you can just remember, okay, I can bring it up, and you don't have to show this, but this h comes up here.
Mhm.
So it's right there. And that's super important because now you get a cancellation. Now your h's cancel. And that's big. I mean, that's the whole problem is you cannot divide by 0, which is why you're doing all this manipulation.
Mhm. Okay.
Okay. And now all of a sudden you can put 0 in for h, not for x, for h. h, not x. -2 over 3x times x plus 0. X plus 0 is 0. 3x squared.
Okay, that makes more sense.
Now, just one or two things here I'll mention is that you're really supposed to work vertically.
Mhm.
You're supposed to write the limit in every step. If you don't, you could be marked off. I mean, I wouldn't care, but they're very, depending on the instructor, they can be really,
Yeah,
picky, and college is different than high school, obviously. So this is one of the variations on the definition of a derivative that you might see.
okay.
Okay, so that takes care of that stuff.
Mhm.
Where should we go next?
We could do the other test prep. I just sent it over because she just sent it to me,
Okay,
but it's preparation for test part 2.
okay. All right, so like the first problem I'm seeing is this like truck rental company. I'll snip it in. I'll snip it in, but
Okay.
this is what I'm seeing. Is this what you'd like us to work on?
Yeah, that's perfect.
Okay. A truck rental company rents a truck for one day and charges according to the number of miles that the truck has driven. Just as an aside here, I started using Grammarly, and it really cleans up stuff like this that's really awkward. I don't know if you're using that at all, but it's like
Yeah, I used to use that.
amazing tools that are available.
Yeah.
Okay, the graph below shows this relationship. So the graph is going up and to the right. And it's like, okay, the more miles, obviously, the more expensive it's going to be. Okay.
Mhm.
So they want you to first write a linear function that relates the cost in dollars of renting the truck to the number of miles, X. So we reasonably assume, I think, that this is X and this is C. And to write the function, you need 2 points in this case. I guess you're supposed to get them from the graph. I don't know. I guess that's the only option. So this first point looks like it's 260, 260, 200 comma 60. And then this other point is like 400 comma 90. And so the slope we need is 90 minus 60 over 400 minus 200. So that's that 30 over 200, 15 over 100. So it's 0.15 dollars per mile. Okay. And then what I guess I would do is I would write it. I know that's kind of this. Let me actually do this, bring this down here. That's actually what we just did is part B.
Mhm.
Okay, but we need that for this first part. So I like to just write y equals mx plus b, and then I switch the variables at the end. So y equals 0.15x plus b. To find b, you could kind of estimate it. It probably is 30, but I would probably put the points in to make sure. So like 60 equals 0.15 times 200 plus b. 0.15 times 200 is 30. 60 equals 30 plus b, or b equals 30. So there's your equation. It's y equals 0.15x plus 30, but they want it in terms of c. So you would say c of x equals 0.15x plus 30. This is not calculus. This is all previous stuff that you're supposed to know.
Mhm.
Right. So the slope, we just found the slope is 15.15. That's dollars per mile. What does the slope in the context of this problem mean? It means that for every mile you drive, it's 15 cents. The cost is 15 cents. So remember in previous classes, they would say interpret.
Yeah.
That's what they're trying to say here. Write a sentence, write a sentence. The y-intercept is the amount that you start with. I'm sorry, the initial cost, like just to get off the truck off the lot is $30. So that's like the flat fixed rate for the day.
Mhm.
Okay. Any is that okay? We'll get part C next, but is that
Yeah, that's
okay?
fine.
Okay. Part C. Part C is how many miles would you drive for a cost of $120? So this is the C value. So your C of X we already wrote as 0.15 X plus 30. So you're substituting that in for the left-hand side and you're solving for X.
Mhm.
So you subtract 30 from both sides, divide by 0.15. And then I'm going to grab a calculator because it's too late to be doing that by hand. 0.15. All right. So 600 miles. Maybe we shouldn't have done that problem. I don't know. Here's a, this is better. This is I guess part 2. Oh, no, that's one said part 1. Let me go grab this
Mhm.
question here. So this is better for us to do,
Okay.
but this could be confusing, I guess. So we'll go through because these are like A through H are kind of all the possible ones that they could ask you, but I mean, they probably wouldn't ask you all of them.
Okay.
Okay, so f of x less than 0. And actually, let me do this slightly differently. This is not going to be helpful for you. Sorry, let me do it slightly differently. Okay. So here's what we're going to do. We're going to do this one at a time.
Mhm.
So here's the graph, and we want where f of x is less than 0. This means below the x-axis. So which points are below the x-axis?
B and E.
Good. We can similarly do f of x greater than 0. That means above the x-axis. That's A, D, and F. I guess C is probably on it, although it's this instructor using some old technology here for that. Okay, now let's move to the part B. Now this is kind of A stuff. We'll go to part B now. Part B says, and I'm gonna do this a couple different ways. F prime of x greater than 0. So in words, this means the graph is going up and to the right. It does not matter whether it's positive or negative. It's literally asking, like, at that point, is the graph going up and to the right? So I'll just give you those 2 points and let you tell me if you agree or disagree that those are going up and to the right.
Yeah, I think.
So like C up and to the right, F up and to the right.
Yeah.
Now, similarly, f prime of x less than 0, so the derivative, this means it's going down and to the right. Down and to the right. So like at A, it's going down and to the right. At
Mhm.
E, it's going down to the right. And the same way at D is a little bit tougher, but it's definitely going down and to the right there.
Okay.
Is that okay? Clear?
Yeah, that makes sense.
Okay. And you gotta know all these, like, even though it doesn't ask, we do have to like get them all kind of consolidated. Okay, let's go to part C.
Mhm.
And part C asks for where f prime of x equals 0. So more generally, this is what's called a horizontal tangent. Did you hear that in class? I know it was online.
No.
Okay. So horizontal tangent, that's and a couple of things that it could be. It could be a min and it could be a max, or it could be something else, which we'll talk about. So do you see how B has a horizontal tangent? Like it's a min.
Mhm.
So the answer is for sure B. Uh, if there were like, if we call that R, which I'm just making up, there's one there. And then if there was this one over here at Q, that
Mhm.
would also be a horizontal change. That's also where this is true.
Okay.
Now, it's not in this diagram, but it's worth discussing, is sometimes graphs look like this.
Mhm.
This is also a horizontal tangent right there.
Okay.
And the slope is equal to 0 at that point. Is this okay? Clear?
Yeah, that makes sense.
Clear?
Mhm.
Okay, now we're gonna do part D. Oh boy. Let's do f prime of x the greatest first. I know that's not the right order. So this is where it's really different and weird. The f prime of x is positive when it's going up and to the right. It's greatest when it's going the most up and to the right. And I'm going to draw two lines here. Which is steeper?
The second one.
The second one. Okay. So if these were our two options, the one on the right is where the derivative is greatest. So you want to think of like steepest slope that you would walk on.
Mhm.
Okay. But it's got to be going up and to the right. So we're basically comparing what's going on at C, roughly that line, to
Mhm.
what's going on at F, roughly that line. Which is steeper?
F.
F. So similarly, for f prime of x smallest, okay, and so there's actually like some WebAssign homeworks where they actually have you like order the steepness of these things. Really
Mhm.
kind of tough. But the smallest, it's now we want the one that's most steep going down the hill, but that doesn't really work. Like think of it, and we don't do this in Arizona, maybe where there's snow where you are now, but like which one would you sled down the fastest now? That's going to be the smallest.
The first one.
Yeah. So A, we're now looking at like the points we said before. So A is going down and to the right, D is going down to the right, and same with E. It looks like A is your
Yeah.
best one there. Are you sure this is in context? I mean,
Yeah.
okay, this, I mean, or like, because we're now going on to second derivative.
Mhm.
Okay, so like F, letter F says, strong color, says f double prime of x less than 0. The second derivative is what's called concavity. If it's less than 0, it means concave down. So there are two possibilities for concave down, something that looks like that, something that looks like that. And like in a classroom, you'd actually see like holding up your hand with the kind of a cupped down, and then concave up is holding your hand like cupped up with some water in it.
Mhm.
And so this is really hard to see visually. So like for example, at B, actually, let me give you the answer and then we'll work backwards. So D, you can actually see kind of that concaveness there.
Mhm.
Maybe you can, maybe you can't. I hope you can.
Yeah, that one probably makes the most sense.
Okay. None of the others, let me look. So C and E are actually look to be like inflection points or really close to it.
Mhm.
But if we go concave up, there's actually a few more of those. So concave up is either holds water. So like at B, it like for sure looks like it's concave up.
Yeah.
And A is actually also concave up. That's pretty reasonable.
Mhm.
Same with F.
Okay.
E
Mhm.
is kind of right on the edge. The inflection point's probably a little further. So probably E is also concave up. Okay. So letter G says F prime of X increasing. This is the same as it asking where it's concave up. It's just another way to ask where it's concave up. Similarly, F prime of X decreasing is asking where it's concave down.
Okay.
But it's not to be confused with F prime of X like greater than 0 does not mean the same thing as this.
Mhm. Okay.
Yeah, it's weird. It's like your instructor didn't. So like some of these say test 1 part 1, some say test 1 part 2, some.
Yeah.
Okay. Let's look at this one. I guess this is kind of a nice kind of like problem from this. So to continue, it's pretty much all we're going to get. Below is a graph of a function f defined from minus infinity to infinity, decreasing and vice versa, as well as changes from concave up to concave down. Okay. So it's increasing. This is where, the definition is really important. It's up and to the right. So you first kind of identify these peaks and valleys,
Mhm.
and then you want the x values. So the x value there is -2, and then the x value there is 2. So it's increasing when it's going up and to the right. And there's really like 1, 2, 3, there's 4 regions here. So in the first region, it's going up and to the right from minus infinity to -2. Do you see that? Up and to the
Yeah.
right. Okay.
Mhm.
Now you have a choice. You can either just list them all that are increasing, or you can just go by interval. So like -2 to 0 is decreasing. So you can throw that in there. And then from 0 to 2, you're back to increasing. But then from 2 to infinity, you're going back down again.
Mhm.
Any questions on that before we look at concavity?
No, those two were like kind of what we did last year, so
Oh,
that
good.
was a refresher.
Good. Okay, so I'm grabbing this picture again so I can redraw it here. The quality of this picture is not very good, but there is what's called an inflection point approximately there and there. And what it does is it changes from concave up to concave down. I don't know if you believe me. I mean, you might say it's a little bit more up or down, but roughly that's where it happens.
Mhm.
So concave up is in the red, and concave down we did in the blue. Okay. So again, they want the x values. So you can either just like this is what I would do at this point. It's concave up. I'll just say roughly it's -1 to -1. Okay,
Mhm.
and then I'm done with that. Like I just do all the concave ups. Or what some students do is they like to start left to right. So like from -infinity to -1, that's concave down.
Mhm.
And then they would write the concave up interval, but then they would say, oh yeah, now it's yet again concave down.
Okay.
Sorry, you might still need to see that. Okay, this is preparation for test 1, part 1, but it's kind of a good problem for us to look at here.
Mhm.
So the ones that are not calculus are, I'll put A, B, C are not calculus.
Okay.
They're just X is -2, go over to -2, go up and find the Y value. Of course, this thing doesn't even have the grid on the Y side. Let me go up and look here. That one doesn't either. Wow. Okay. Well, call that 5, we'll say. So f of -2 is 5. F of 3, it looks like it's 0. F of 0 is also 0. Okay, so nothing there that's new. F prime of -2, though, that is new. It's asking for the derivative at -2. And I've mentioned this idea of a tangent line. So there's -2. It's a tangent line. It only touches in one place. If you remember from geometry, a tangent only touches a circle in one place.
Mhm.
That was horribly drawn. There you go. Something like that. So it only touches the curve in one place. That's the idea of a tangent. And at a peak or a valley, it's that. Now, that is not the answer. The answer is, what is the slope of this? What is the slope of a horizontal line? And that's 0. So let's go to F, letter F first. Next, F prime of 0. So at 0, again, do you see that there's a horizontal tangent there? And the derivative means slope at a point, slope at a point. So the slope at that point is 0.
Okay.
Now F prime of 3, that's the hardest one here. And you if you go over to where 3 is, you have to estimate this tangent line
Mhm.
like that. And so you really don't have enough information to do this, but you're trying to find the slope of this line.
Okay.
So this is not a good drawing, but there are problems where you get a way to kind of approximate it. Now, for sure, it's negative. Why is that? Why is the slope here negative?
Because it's going down.
It's going down. So like at a minimum, you got to do that. I mean, the slope of -1 is kind of a 45 degrees. So it's definitely bigger than -1, or or it's negative, but the number is bigger than 1. So I don't know. You could put in like -10. That's probably, not far off on that.
Okay.
When is your exam?
It's due like by the end of the week. Like I could take it whenever.
Okay. Yeah, that's one of the nice things about college. Sometimes you get a little more flexibility on stuff, and
Yeah.
you don't have to do it at the same time
Mhm.
as everyone else. Okay. Another question here. So this is not a calculus thing. They're asking for the average rate of change. They're asking for AROC, average rate of change. They give you an A, they give you a B, average rate of change. is defined as f of b minus f of a over b minus a. So you're going to go to your table and you've got to find f of 12, f of 4, and get those values. I guess this one's f of x. Again, you're kind of missing because they're usually in alphabetical order. We'll go with that. So can you tell me the value of f of 12?
It would be 19.
19 minus f of 4, which is 40. Okay, over 12 minus 4. And you get a number for that. You've done that before.
Mm-hmm.
Sorry, my computer's just froze up slightly. All right, now we're good. Okay, for part B, it asks about whether they are linear or not linear, so on, so on. Okay. Sorry, let me get this snipped in here. And then let me grab the table one more time. Okay, do you remember the requirement for linear?
I don't think so.
Okay, so it either goes up or down by the same amount.
Oh yeah.
So
Okay.
40 to the 31 is down by 9, but then it's down by 12, then it's down by 15. Okay, so that's definitely not linear. But the next one goes down by 9, down by 9, and down by 9. So that's linear. So we got F, G, and H. So G is linear. Now, is it increasing or decreasing? And that's simply a matter of like, is it going up or is it going down?
Yeah, so it's decreasing.
It's decreasing. Okay, which means that in our case, it would have a negative slope.
Mhm.
So the best way to do the next ones are to actually, so like linear is the easiest one to figure out. So the other ones are nonlinear. So we can say that F and H are nonlinear. Okay. But to actually answer the question of like, is F concave up or down? Because we can tell whether it's decreasing or increasing just by the graph.
Mhm.
Okay. Is to actually make a quick, like a really rough sketch of X and like F, for example. So here's 40, 30, I'm sorry, here's 440 right there. 831 is obviously down, okay? But is the next point, what you have to decide here is the next point down here or up here? And that'll help to give you some ideas. So 1219, it's actually down here. So that's telling you kind of this shape
Mhm.
of it. And then 16.4 is here roughly.
Okay.
Okay. The other thing you can do is look for the difference between the points to see if it's getting bigger or smaller. So the difference between 40 and 31 is 9. 31 and 19 is 12, 19, and that's 15.
Mhm.
And then if the difference is getting bigger, that tells you whether it's concave up or concave down. I think it's easier to make a rough sketch. Like here's X and here's H. 440, 851, and then 1259. So this one's actually bending the other, kind of the other way.
Mhm.
Again, that's from the difference. The difference is it's 11, and then it's 8, and then it's 6. So the difference is getting smaller. That's why it has this sort of shape to it.
Yeah.
So down, down, and so on. All right, well, we are out of time for tonight. I hope this helped you.
Yeah, it did help me.
If you're not in Arizona time anymore, and you,
Oh, I go to the U of A.
okay,
Yeah.
all right, I didn't know.
Right.
But if you ever need a lesson and you don't see something available, just text or email and I'll let you know if I can, squeeze you in
Okay.
for this. But thanks for scheduling. I'll send you the notes here shortly and I'll see you next time.
All right, perfect. Thank you.
Have a great night. Bye now.